All right, we're going to start. The first thing that I want to show you, and I want to make sure you hear this, I'm going to have to send out a note on this to people, etc. But you may or may not have seen this before, but I showed you the books that I'm going to be using for fall. All right, there, and believe it or not, there's a reason I'm doing this. It's not to waste my time or your time. All right, the main reason is this is the book for the C class. If you bought it already, return it. If you haven't bought it, don't buy it. It's a good book, but it's a book all on theory. And there's basically no examples in there. I went back and I was rereading it over the weekend, and it's like, I'm like, Jeff, why did you pick this book? The good news is I'm looking and it says, at least through Amazon, they're out of stock. So my hope is if I go over to the bookstore and I tell them they can still stop the order. Instead, what I did was I went out to a free site, which is the itebooks.info, and what I found out there, I'm not going to go through it, but just so you know, I checked C, and they had 10 pages worth of C stuff. So I've already put out on the P drive for the class, not for this class, but for the class next semester, all right, under PDFs, there's a thing that says C, and it says Fall 2016, all right? And there's a couple of PDFs here, and they're going to stay here. This one is called C in a Nutshell, and it's wow, 620 pages. No, we're only going to go through about the first third, because that goes through C specifics, let's just say. The other one, the hardest part of understanding anything in C is understanding pointers, and this is a book on pointers. Now, I could go through each page of that, and more than anything else, it would make your head hurt. Seriously, I'm not trying to be funny at all. But we will go over some of the stuff from each one of those books. But still, the idea is to do that over 9 or 10 weeks. So we have somewhere between 6 and 8 weeks to go over the iOS stuff. If you have not heard this, might not sound like a big thing to you, but it's a big thing to instructors. That what they started doing this year, they've never done this before. All right, so you as first-year people are the inaugural group. You've only had 16-week semesters. When I started here, we had 18-week semesters. Then it went down to 17-week semesters, and we had to do what was called value-added time. So we had to come in here on our own and do things and prove that we were doing stuff, etc. Then they went down to 16, okay? So now what they're saying is, well, since you're not working that one, they want us to take a furlough. And they want each person to give up an average of about $2,000 out of their check per year. Okay? And then they're wondering why there are people here who are either retiring or who are getting upset. And they're like, well, don't worry, because we're taking a furlough too. The difference is we have not had a raise now in 3 years, and they give neither have they, but they give themselves reviews at mid-year, which we don't get. And for the last couple of years, they've taken whatever happens at those reviews, and they pretty much have kept them private rather than public. So some of the people I've seen, some of the stuff, have been bumped up as much as close to $10,000. Yeah. While the rest of us are sitting there and being asked to give up $2,000. Okay. All right. So, like I said, and I will try to remember to do that this weekend and put it into put it online for everybody who's in that secure coding class. But if you did get the book and you open it up and you've already started reading it, or they won't give you money back, talk to me and I'll see what I can do about it, okay? My publishing rep is not going to be happy. I'm using less books from him than I usually do anyway. And when I first started reading this book, I liked it. But I was reading it inside of a Borders. I must have picked the right chapter, because I started at the beginning this time and I didn't like it at all. All right. So what I want to show you here and what I put down, we can do this together. You can watch me do it. We can talk through it, whatever way is easiest for you. But if we look in here, what I've done is I've got this, remember this program we did in Java, this array fun? All right. Well, the second handout that I gave you is the same one rewritten in C. So the first thing I'd like to do is just talk to you about some of the stuff that's in here, just so you hear it. Do I expect you to remember it? No. Do I expect you to understand it? Some of it. Because there's a natural correlation between this language and Java. All right? There's a natural correlation between this language and a lot of other languages. All right? You can see comments are the same here, whether they're single or double. But let's just take a look at some of the differences. Well, you'll notice that outside of everything, when this is how you create a constant. You say pound define, you give it a name, and you give it a value. This is a numeric constant, but you can make string constants that you put in double quotes or whatever too. All right? This looks a little weird. You know how maybe you've noticed this, maybe you haven't, but in Java I know you have. We do our import statement. All right, and there's something similar that you do in C# also. This is how you do it in C. But it's a little bit different in that, notice you define constants, you include files. If you include a file that's in angle brackets like that, what that means is it's a system file. If I create my own file, and I call it jeff.h, then I put it in double quotes as opposed to angle brackets. So when the system sees something in angle brackets, it says, oh, that's a system file. When it sees something in double quotes, it says, oh, that's your file. Make sense? All right. And the stuff that's in here, just so you know, I didn't totally take advantage of it. I forgot. Actually, maybe I did go back and add that line. We'll see. But you put this in basically every single C programming line there is. All right? You're used to doing system.out.println, for example, in Java. You do a printf in C. Okay? And that stands for actually print formatted. And printf is defined in the file stdio.h. Okay? When you do input in C, you use something that's called scanf. You'll see an example of it in just a minute. But printf and scanf are formally defined in the file that's called stdio.h. Anybody want to take a guess as to what stdio.h stands for? Standard input output. And these files where you put basically all of your function libraries, they're called header files. That's why they must have a .h extension on them. Okay? All right. You've got your choice when you work with C. This is main, and it's a very similar main to the kind of main that it doesn't look exactly the same, but it's similar to what you'd write like in Java, for example. All right? I'm used to putting main at the top of the program. Okay? But, for instance, notice that main is referring to a function here called menu and another one that's called call correct function. All right. Since those things, since menu and call correct function are both below main, what I have to do at the top of the program is create what are called function prototypes. And what that does is it lets the compiler know, hey, in your program, you will have these functions. You will have a function called menu that does not take any parameters, but will return an integer. All the other functions that are in there return nothing. Some of them have no parameters. One or two of them have an int, and this last one has an integer array. Does that make sense? All right. So when you're prototyping, that's what you're doing. You're letting the compiler know, hey, this stuff is defined later on in my program, so just so you know that it's there. You're like, well, what if I don't put that in? Typically, it won't compile without it. And if you say, well, what else can I do? If you put main at the bottom of the program, then typically you don't need to do these prototypes. But the problem is, if you put main down at the bottom of the program, all right, it may get lost. All right, so what you're encouraged to do is to do it the way I showed it here. All right, I tried to come up with pretty much the same names that we had in the Java one. All right, so are these the best names in the world? Heck, of course not. But they're pretty descriptive of what's going on. You already know what void means. You already know what int means. And, if you look in here for int and for int star, it's like, well, wait a minute, what does that mean? The compiler could care less what name you're going to call that integer and what name you're going to call that integer array. All it wants to know is that you've got these 10 or so functions in here, what their names are, what type of values they require to be put in the parentheses, and what type of value they'll return. Okay? Does it sort of make sense? All right.
Would that be the .h file then?
Well, typically what ends up happening, if I write a hard enough, complex enough program, I'm going to have so many of these, tell me if I'm answering your question, that I might take all these and put them in my own .h file. I can do that, yes.
Okay.
And then reference it up here.
Yeah, because
Yes.
I know in Objective-C that is that you have to do that
Yes.
that way. Yeah, .h and
Yeah. Objective-C is a derelict of C.
Yeah, I know.
Yeah.
It's basically
Yeah. But with Objective-C, everything's a pointer. In C, typically you've got your choice of what's a pointer and what's not a pointer. All right. Global variables, kind of like what we had in Java, but in Java you've got that public class at the top. You don't have classes. This is a non-object-oriented language. So if you want to create global variables, they have to be declared outside of anything else. Now, I hate telling you this, but I just want you to know it. Literally, it's possible with these global variables, I could have literally taken them and put them, for example, in here. As long as they're in some place that's not inside of a function. Historically, programmers put them at the top of the program. Some programmers put their include files, then their constants, etc., then their prototype. It's not that important the order in which you do it. The fact that you do it, that's what's important. All right? So if you look in here, what I did was for these global variables, I created 3 of them. All right? And the first 2 might look a little funky. What happens is when C does assignment, it does it from right to left. So literally what this does, you could probably guess, in those first 2 lines, in lines 61 and 62, it creates 2 arrays, one called orig numbers for the original array, and one called copy numbers for the copy of the original. All right, they both have 25 elements, meaning their elements are 0 to 24. All right, and since you put the 0 in curly brackets there, what that does is it automatically initializes every member of that array to 0. And that would work whether that's 25 or 25 million, which is kind of a nice way to do it. I literally could take the time if I wanted to. I could say 0, 0, 0, 0, 0, 0, and make 5 rows of that. You can do that. All right, but this will work just fine. All right, and I've got, so those are my two arrays, and then I also created this, and I'll explain that a little bit later. But max was set up to 25 because there's 25 things in there, and I set this to max minus 1. I may or may not have shown you this back in the Java time, but the reason I did it like this is so when all 25 numbers print out, I want a comma after each number, except the last one. I don't want a comma there, because I think that looks bad. 1 comma, 2 comma, and then the last one, the 25 comma, etc. That just looks bad. All right? So when I go through this, and I'm actually printing out those values, I'm only going to print through max minus 1. Then when I fall out of that loop, then I'll print the last one because then it won't have a comma after it. All right. So you don't always see main written like this. There's different ways that you'll see main written. All right. But you'll typically either see it as void main void, like we have right here, or you'll see it as int main void, in which case I'd have to return 0. And I'm showing you those because those are the 2 that you'll see the most often. There actually are 2 different things. They're very similar. If you remember the way that we've got it set up in Java, where we say, static void main, and then inside of there it says string bracket bracket args. Typically what you have here is something called argv and something called argc. And argv is a listing of everything that you can, if you want to, pass into main. Those are all the strings. It's called argv for argument vector. All right? And argc stands for argument count because it keeps track of how many things you passed in. I don't want to get into that right now, so I just kept it simple like this. All right? So when we start, at least, we'll just do it like this. Whoops. So again, meaning this returns nothing and nothing is passed in. That should make sense to everyone. All right? Just to show you what this looks like, and believe me, this is totally non-GUI, but I just want to show it to you. All right? So this is how we're going to actually run things here. So this is array fun 2, CL, which means compile and link the program, arrayfun2.c, and I hit enter. If it comes back like this, there are no errors in there, which means it's done the compile and it's done the link. Why am I telling you that? Well, if I put this into a folder to show you that when you do this, it builds some stuff here for you. It builds a .obj file and it builds a .exe file. So it's ready to be executed right now. And the way that I literally execute this is all I type in now is the name of the program, arrayfun2. All right, this is what I wrote. Very simple little menu, a 0 to, you saw that before. This is the same way we did this in Java. All right, so if I come through here and I type in a 1, it says new array values generated. You say, well, geez, I don't believe you. Well, then I can put in a 2 and I can print those out. Now, it's kind of hard to see because of the way this wraps. And once you've set this up, this window, you can't change the size of it. All right? Well, I can. How's that? So, but what I'm saying is 54, 59, notice that everyone has a comma except which one? The last one. Because to me, that looks amateurish. So that's why I only went up to there, and I made sure there was a comma and a space after each one, but then when we came to the last one, I said just print it out the way it is. All right? So you'll have to show me that later. All right. So there's the original array. Now if you look in here, and I'm just doing this off the top of my head quick, it looks like 4 is the smallest number. Just taking a very quick look, and it looks like 97 is the largest number, but we can find out, so we can print 3 for the smallest, 4 for the largest, 97. Or I can come in here and I can put them into ascending order, into descending order. I can add up all the elements. I can add up all the elements and divide by 25. Does that make sense what's going on here? Because this is run the exact same way as the way that I showed you, that we the same way that we did the Java one. And a reason I decided to do this one, and just so you know, you've got hard copies, but there's also there are 3 copies. There are 3 C programs, I believe it is, out also on the P drive, and it's the same ones that you got. And then I made some changes to the original, but I'll put the original out there too. All right. So, anybody want to take a wild guess over what that does? Line 69 there. That's a way in C that you can write an infinite loop. All right, because it just compares 1. It says, oh, well, yeah, that's true. So it'll go forever. You can also, if you want, instead of saying that, you can type in 4 like that. That also will give you an infinite loop. All right. So what this is saying is forever, this selection, and this selection is going to be whichever one of these that we put in there, that 0, 1, 2, 3, 4, 5, 6, 7, or 8. All right. So this selection is going to be equal to menu. So what the hell is menu? Well, notice I get to menu, and I've got a new variable, a local variable called selection. I just set it to -1. Then I call show choices. Does it make sense when you look at this right here? This right here that you see in gray is this right here. Okay? But it's not like we have it in Java where we create a string and we keep concatenating onto it. This is the easiest way of doing it here. C allows you to use strings, but they're not nearly as user-friendly as they are in a language like Java. All right? Technically in C, it depends on the book you read, but technically in C, all right, everything, when you work with a string, it's really a character array. All right? And there's a lot of different things, and we'll go over some of that stuff next semester. But again, if you notice, printf, I didn't have to put a space here, but I did, so it read a little better. \n, you're used to that. That's a new line. Nothing new there. And this is just regular text. All right? So what I'm telling it to do is to call this, so I want to print that. Okay? Then I want to come in here, and this is my input statement. It looks a little bit weird. Anytime you see a % sign like this in here, it's a placeholder. All right, so D actually stands for decimal integer. You can use I. I've used D all my life. I'm just used to using D. But I for integer will work also. If you want to read in a float or if you want to read in a double, either one of those, you use an F. Okay? And here we're doing a little bit of validation. So while that selection is less than 0 or greater than 8, because our only choices are 0 through 8. All right, now I could have come in here and I could have created up here, I could have put some more constants in there and I could have called it min selection and set it equal to 0 and max selection and set it equal to 8. And then I could have changed that to min selection and max selection. Okay? But all this is saying is if I put in a number that's out of range, okay, don't accept it. The bad thing is, what if I do this? All right, please enter 0 through 8 now. All right, I'm not going to enter anything. Okay, well, now it's waiting. So I'll put in, I don't know. Well, you can see it doesn't like that very much. Unlike what you see in Java, where you would have gotten an exception right there, this doesn't throw exceptions. The program just blows up. So when you're looking for something, and you can't write natural exceptions in this language. We'll talk about later how you get around this. You can read things into strings, okay? And then there's, for example, there's a function, if I wanted to use it here, that's called A to I. A, letter A, T-O, the word to, I, for integer, which will attempt to take an ASCII string and convert it to an integer. All right, so we'll talk about that stuff as we go on. So if this fails, just go back and do it again. So ideally, when we get down to here, does this make sense to everyone? When you get down to that line, you have to have put in a number between 0 and 8 for selection. So that's what you end up returning here. So now that we've got a number that's between 0 and 8, now we call a function called callCorrectFunction, and we pass it in that number between 0 and 8. Why? Because we're going to do our old switch statement in here. All right? The switch is set up almost identically to the way that it is in Java. All right? And Corey mentioned he talked a bit about Objective-C, and it would look pretty much like that in here too. The newer language, the one that you'll be learning when a year from now for the iOS class, is a language called Swift. In there, you don't even have the break statement in there anymore. Okay? As soon as it finds something, it does it, it gets the heck out by itself. All right, so this says if I enter it as 0, well, look at what we want to do. 0 means end the program. 1 means create a new array. 2 means show me the original array. 3 means smallest. 4 means largest. 5 is ascending. 6 is descending. 7 is sum, and 8 is average. So if I put in a 0, I want to get out. So I said normal program termination. Remember how we say in Java system.exit? There is no system here. It's just exit. And 0 in this language means normal program termination. All right, so you're just exiting normally. All right, if it's a 1, we want to create a new array. If it's a 2, we want to show the original array. If it's a 3, we want to show the smallest array element. If it's a 4, we want to show the largest array element. If it's a 5, we want to show the array in ascending order, a 6 in descending order. If it's a 7, we want to add up all the array elements. And if it's an 8, we want to add up all the array elements and divide it by 25. Does all that make sense? All right. You'll notice if you look on the top here that I actually have 2 arrays. What I do is I fill up the array called orig numbers with 25 random numbers. That's the original numbers that were generated in that order. But then as I put them in, I copy them from this array to this array. Because the array that I want to manipulate, I want to be able to put it in ascending order or descending order, is the one called copy numbers. And these names aren't great, but I thought they were fairly reflective of what I was trying to do here. Now, some of this stuff, you look at it and you go, wow, that looks virtually identical to the way that we did it in Java. And it pretty much is. This, I don't know if I mentioned this to you or not. I actually, if you want, I could comment this line out. Then what you'll notice is virtually every time I run the program, all right, so if I stop the run and I run the program again and then stop it and run it again, I get the same 25 numbers because it's not seeding the rand. All right, this where it says srand, all right, that's actually S is for seed the rand. So it needs some kind of a different number. But rather than generating a random number here, what it does is it grabs the current system time. And it does it down to the 100th of a second. So if I go like this, those are 2 different times. Because I can't snap my fingers and not have at least 100th of a second go by, type of an idea. So again, this is saying right here, seed the rand. Then what we're doing right here is, this is how we generate random numbers. All right, we call a function called rand. We modulo it by 100, and we add 1 to it. Rand by itself will actually give you integers. Okay? But since we're moduloing it by 100 and adding 1 to it, this will give us something between 1 and 100, which is what I wanted here. So this is going to give me 25 random numbers in here, in each one of those 25 array locations, locations 0 through 24. As I get them in, I'm immediately copying them over to the other array. This is, again, is the array that I'm going to manipulate. All right? Then when I'm all done, I just gave a message that said the values have been generated. All right? When I want to show the original array contents, what I ended up doing in here, there's an array fun that you have in yours, and there's an array fun2. This array fun2, I wrote another function right here called print array that's down at the bottom. There it is. I was actually doing this 3 or 4 times in the program. So rather than taking all this, and it's not much code, but it's 5, 6 lines of code, rather than having it in there 3 times, I pulled it out and then called it 3 times. Does that make sense? All right. The smallest, this is virtually the same thing as the way you did it in Java. So look at that, and now let's look at how we did it in Java. There's display smallest element right there. All right, and there's a way to do this. I don't remember what it is now. There's somewhere in here it says line, but I don't remember where it is, where I can open this into 2 windows, but I don't remember how to do it. It's not going to split it the way I think it's going to split it, no. Well, I don't remember, but the point is, take a look at that. Int smallest equal number 0. We've got an array that goes through from element 1 through the rest, and if it finds one smaller, it becomes the new smallest. Well, looks pretty darn close to the same thing we're doing here. Other than the variable names, the code is identical. Also, the code here and the code here is identical. The only difference is here I called it smallest, here I called it largest, here I said less than, and here I said greater than. Other than that, it's the same exact, all right, it's the same exact thing. All right. In ascending order and descending order, I just took the same exact simple sort that I used for Java And all I did was, again, in Java, we had different array names. Other than that, these look identical. All right? The sum is identical. So if I've got 25, imagine it generated the numbers. It wouldn't, but imagine it generated the numbers 1 through 25. Those were my random numbers. This is saying 1 plus 2 plus 3 plus 4 plus 5 all the way to 25. All right? And then I redid it here. I didn't have to do it like this, but this is just the way I did it. And then I said, okay, divide it by 25. Remember what this is called when I do this? When I put that in parens? It's cast. You cast in here similarly to the way you cast in Java. All right, then we print it out. Now, a week or so ago, I gave you a copy, and I still have one or two here probably if you don't have it, but for the Java class of the calculator that we're going to create, the non-GUI calculator. We're going to do that next Monday. We're going to go through that, and then we're going to look at how we would actually add error handling, all right, in Java. But the point is, this is the same program. This one, the one that's called calculator.c, the other handout I gave you, is the same program, but I wrote it in C. So you'll see if we grab that one, let's see. All right, so this is calculator.c. All right, so I type in calculator. You have to spell it right. Input a number, 47. All right, I put that in there just because it wasn't working at first. That was my own ignorance. Put in another number, 25. All right, so enter a 1 to add them, a 2 to subtract, etc. So if I put in a 1, it's pretty obvious what's going on in there. It's pretty simply done. All right, but what you're going to have after next week is you're going to have this. All right, and again, it was just the idea here was just to show you what was going on here. All right, and you're also going to have the Java one. You know, if you want this one, or this one is out there, but if you want the Java one, you have to type it in. All right, and that's my hope is that we'll do that as a class on Monday. And then when we run it in Java, I'm purposely going to put mistakes in there so you can see what the mistakes are and how it generates exceptions, and then we're going to fix those exceptions. All right, we're going to do that. That's what we're going to do on Monday. Then on Wednesday, we're going to do the same program, but we're going to do it GUIized in Eclipse. So you can see the difference between doing GUI programs and non-GUI programs. All right? C is not a language that has been set up for you to do GUIs. I'm not saying you can't do GUI things in C. I'm not saying that. But it is not a GUI language. All right? And just so you know, so how am I doing the compiling and all this other stuff, this window, etc.? If I go out here to my start and I go to all programs and I go to Visual Studio, wherever the heck it is, Visual Studio 2013. Do you notice what I have underneath there? If I look long enough, there's a Visual Studio Tools, and underneath that, all right, then maybe there it's in here. That's the developer command prompt. That's what I'm using. There are probably, I'm not going to do this. If I went out onto wikipedia.org right now and I typed in C compilers, all right, I'd probably find somewhere in the area of 100 of them. All right, and out of those 100, approximately a third to a half would be free ones. I just use this because it's there and it's fairly simple to use. If you disagree and you say I'd rather use it, I guess from what I understand, I've never taken the time to investigate it, but I believe that you can actually go and create this stuff inside of regular Visual Studio. You want to check that out, you can. I don't care. I mean, when you get done with your programs and you give me your .c file, you're not going to have to give me this stuff, the .exes and the .objs. I'm going to always go and recompile your programs anyway. Well, you don't trust us. I just want to make sure that they compile. That's all. It's the same kind of thing, whether you know this or not. What I end up doing in Java, all right, I tried doing it a bunch of different ways, but the easiest way that I have found out is in Java, I take all of your code and other than my line that's got the name of my class, my beginning curly and my ending curly, I just have nothing in between there. And I copy your stuff in. And I run it like that. That's the best way for me to do it. All right? And which is a pain in the butt because unless I tell you all what I want you to call something, all right, I end up having to make a lot of changes in the code. It's okay. All right, I probably should have a better standard for how you name things. All right, so that's what this class will be about. And again, just so you see this, I know I mentioned it before, but I want to say it again. This C in a Nutshell book, again, if we look at the table of contents, yeah, there's 620 pages in here. I mean, literally the first week, we're going to go over language basics, types, literals, type conversions, expressions and operators, statements, functions, and maybe even arrays. All the first week. You're that good. And it's because there really are very few differences between that and what you get in Java. All right? Then we get the pointers. And pointers are kind of an anomaly. There are very few languages that allow you to directly work with pointers. And all a pointer is it's something that points to an address in memory. All right? But it allows you to do a lot of really cool things. So we'll spend probably at least a week just on that chapter, even though it's not that long. So I can give you a bunch of examples, and we can look at the other book too. Okay, then we jump back into this one. Structures, unions, and bit fields. And the key one there is structures, because that's how you create the equivalent of a record in this language. All right? This language is like Java in that, for example, when you create an array, you can't change its size, and every element in the array must be the same type of variable. So I can have an array of ints, I can have an array of floats, etc., but I can't mix and match. All right. Then, because this is very similar, the declaration, that won't take long at all. But the dynamic memory management, that literally is, if you look at that, allocating memory dynamically. That's how you get around the fact, because if you used a language like C, where you have to up front say, my array is going to be this size, this is going to be this size, this is going to be this size. Well, then how would you ever be able to add records and remove records? All right, that's where the dynamic memory allocation comes in. You, as a developer, are responsible for dynamic memory allocation. What that means is not only do you allocate the memory, but when you're done using it, it's up to you to deallocate it, to give it back to the system. And again, I go back, and you've heard me say this, or you've seen this yourself, to the old blue screen of death. All right, it still is, from what I've read, the majority of programs today that are written out there, application programs, are written in C++. All right. Now, that said, almost all of those programs use libraries. You want to take a wild guess over what language those libraries are all written in? Because it's C. And if there's something in there where you fail to deallocate memory, all right, that's where you get those blue screens of death, or the program just blows up, or whatever. All right. Input and output, not very hard. The preprocessing director, there's a few more things than what I told you as far as the pound include and stuff like that. You can actually do programming in your pound include files. And what I mean by that is you can have like pound if, and then what they call pound phi, which is if backwards. So in other words, you can say if a certain condition is true, I want to include this stuff. Otherwise, I want to include this stuff, type of thing. So we'll talk a little bit about that. And then we'll look at the standard headers and the functions at a glance. I'm not going to go over compiling with GCC because that's a Unix or Linux compiler. I'm not going to go through that. I'm not going to go through this. So you notice that already, the standard library functions, there's 200 pages that just show you in this book what all the major functions that are provided in the language are. I'm not going to go over those, but they're there for you if you need them. All right. Then it goes, with a compiler, and that's about X number of pages. How to build C programs. This stuff that's right here is more Linux based. So what we'll do is go over these first 16 chapters from this book, and then from the other book, it's got a nice cow on it, and then from the other book, not there. All right, which has got a bird on it, and this book is about 200 pages. All right, and you'll notice it's got about 8 chapters. And it shows you some of the power. What happens is, if you actually take the time to read both these books, I'm not saying you will or you won't, but if you do, you start looking and you go, wait a minute, you know what? Some of that stuff is a lot like what we have in JavaScript when you can work with anonymous functions. And so, yeah, that's where it all came from, was from here. All right. So I didn't know what you'd want to do. I didn't know if people felt like keying stuff in. So I keyed it in for you. All right. Next week, we're going to do a similar type of thing, but I'm going to have you create at least one web page in Bootstrap so you can see and go through the steps of doing it. Also, if I have the time, what I'm going to try to do, if I remember this and if I have the time, is the same program, not the calculator, but the other one that's got all the array stuff in it, the array fun program. And if there's time to calculate, I want to write those two in PHP and give you a copy of each one of those just so you can see what it looks like. All right. And when I'm writing this stuff, I'm writing it as simplistically as I can because I want it to make sense to you. So, if you look at it, if you know PHP, why didn't you do this? I did it because I wanted to keep it as simple as possible. All right. Any questions? Because that's what I had.
Split screen in Notepad++.
Yeah.
Right click on the tab and say move to new view, I think it is. Other view, down towards the bottom there.
I believe you. There's another way of doing it. One of these things in here, and the wordage is weird, but I remember looking at it, and I don't remember which one it was. That's not that.
Is it F8 maybe?
There actually is a thing on here, but the word that they use is a weird word. Well, that's what you've got. That's not, there's another way of doing it, because I remember thinking the word for doing it was so stupid it didn't really make any sense. All right, but this is what you said. Right-click on the tab and select Move to Other View. So I only have one open here, so let's open a couple of them. Right-click. Okay. All right. Thank you. And I've got to find out that other way to fix that, the size of that window too. Like I said, I know it's simple. I just never took the time to learn how to do it. Sometimes people say that you might have, yeah, probably in like 2000. But people will say that, well, how come you know how to do all this, but you don't know how to do this? I knew how, but I had my moment where I forgot how to do that. So.